Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Muizzuddin Ruzlan. Today I'm gonna present about Lab 2 Microprocessor. For the questions, our team got the first question, which is based on figure Q1, construct and execute an assembly programs that turns on LED0 to LED7 connected at port PB0 to PB7 on 1 by 1 from LED0 to LED7 as a running light. When the switch B1 user button is pressed, next when the external switch PC1 is pressed, the LED7 to LED0 turn on 1 by 1 as running light. This question means when we press the switch B1, the LED will turn on 1 by 1 from LED0 at port PB0 to LED7 at port PB7 as a running light. When the external switch PC1 is pressed, the LED will turn on from LED7 up to LED0 one by one as a running light. Now we move to schematic diagram. Our schematic diagram is a little bit different with the original schematic diagram, since there are a little bit problem with the original schematic diagram. We change the input port and output port. First, the input port. We change from PC1 and PC13 to PB0 and PB2, since the PC13 is not suitable for use. For the output port, we change from port B to port C, since at port B there are some port that can be used like PB3 and PB5. So for the input, the switch is active low since it's close to ground, and for the output LED, the LED is active high since it has ground.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hamdi Rahman bin Raslan, and I'm going to show you our flowchart. We start off by declaring all the GPIO configuration such as RCC AHB1ENR, GPIO-C model, GPIO-B model, GPIO-B IDR, GPIO-C ODR. Then the program will store 6 in hexadecimal value to the memory address pointed by RCC AHB1ENR to enable pin for port B and port C. At port C, pin 0 to pin 7 will be set as output, and port B, pin 0 and pin 2 will be set as input. When the user presses the button connected to pin 0, a forward running light sequence will start, meaning it will first turn on LED 0, and then after a brief delay, it will turn it off and the next LED will turn on. This will continue until LED 7. When button connected to input pin B2 or button 2, the reverse running light sequence will start, meaning it will first light up LED 7 and then after a short delay turn it off and the previous LED will turn on. In this case LED 6 and so on until LED 0.
Assalamualaikum and hi, my name is Muhammad Mehazib bin Muhammad Isri and my student ID is 2025237022. So right now I'm going to tabulate the GPIO configuration table. So as you can see from the slide, there are 5 steps that we need to know. So first thing first, we need to declare our port. By using RCC H1BNR, we can declare our port B and port C. So the next thing we need to declare is our output is by using GPIO model and using BIC and ORR. So after finish with our output, we need to declare our input by using GPIO model 2 but only with BIC. So the next thing we need to declare is for selecting our push button by masking both of them, since we have 2 push button which is at port B0 and port B2. Next thing, we need to declare our pattern, which is by using LSF for the forward pattern and LSR for the reverse pattern. Hi, right now we are at step to declaring our port by using RCC AH1BNR configuration table. So, to declare our which port are we using, we need to put the binary one to which port that are we using. So, for our case, we are using port B and port C. So for the first table, we are going to input the binary 1 to port B. And for the second table, we are going to put binary 1 to port C. Okay, so right now we are at step to declare our output and input. So for our output, we are going to use BIC and ORR. Since we know that our LEDs is from PC0 to PC7, we are going to put the value 11, which is in analog mode, into BIC. And we are going to import value 01, which is general purpose output mode, into ORR from PC0 to PC7. And the output that we will get, which is BIC 0x000FFFF. And for our ORR, which is 0x0005555. So the next thing we are going to declare is for our input. And for input, we are going to use only BIC. So since we know that BIC are going to use 11, so for our input, we know that we have two push button which is PB0 and PB2. So for PB0, we are going to put value 11 into PB0 and value 11 into PB2. So the value that we will get after that, which is BIC 0x00000033.
Now we move to masking. There will be two things that will be masking. So the first one is PB0 and the second one is PB2. So what is masking? Masking is when we want to initialize the port that we want to use as an input. So at the first table, we can see for masking PB0, we will declare 1 at the port that we want, which is port 0. So the masking will be 0, 0, 0, 0, 0, 0, 0, 0, 1, which is 1 at the 1, which is 0, 0, 0, 1 at the port 0. Then we go to declaration for when the PB0 is pushed. So since the push button is active low, will be put the number 0 at the port we want, which is port 0, port B0. So will be, for the table 2, we can see that at port B0, the number is 0, but as we know, active low is active at 0 and not active at 1. Why the other column is not 1? Because of masking. We're already masking for the port B0. So the number that only changed is for the port that we masking for. So the other port will be 0, 0, 0, 0. So for the PB0, when it push is 0, 0, 0, 0, 0, 0, 0, 0. So for the port B2, for the port B2, for the masking, will we put the value 1 at port B0, which will be the 4 last number will be 0, 1, 0, 0, which is 4, and the total masking will be 0, 0, 0, 0, 0, 0, 0, 4. So we go on to when port B2 when the push button is pushed at port B2, we will declare the number 0 since the push button is active low. So it will be the same as the PB0. It will be 0, 0, 0, 0, 0, 0, 0, since for the masking, the other port will be 0 and the port that we will use will be 0.
So right now we are at the step for declaring our pattern. Since we know that our question require us to move the LEDs by sequence for each LEDs, which is we are going to use pass the value 1 LED at a time. So the best solution that we have come out with by using left shift, left for the forward sequence and right for the reverse sequence. So from PC0 to PC7, we are going to use left shift left at the forward sequence. So it will pass the value 1 at this PC0 to PC2, PC3, PC4 until PC7 for the forward sequence. So for the reverse sequence, we are going to pass the value 1 from PC7 until PC0 until we get the reverse sequence of the LEDs.
This is the program code. All the GPIO configurations are declared here. In the main loop, RCC AHB1ENR is used to declare port B and port C by storing value of 6 in hexadecimal to that address. GPIO-C model and GPIO-B model is declared for both the output and the input respectively. The program will then perform a masking. Masking is to make sure that only the desired input will trigger an output. In this case, when the user press either button 1 or button 2, a running right sequence or a reverse running light sequence will start. There are two functions in the program. Forward sequence will light up LED 0 by storing the value 0x01 to memory address pointed by GPIOC ODR. Then the program loads R0 with value of 200 in decimal to add for the delay, and using LSL or logarithmic shift left to shift the number to the left by 1 bit. This is done to turn on the next LED and to turn off the current LED. The program will continue this loop until the final LED is light up, or when the value stored in GPIOC IDR is equals to 0x100, and then it will branch back to the main loop. The reverse sequence will first light up LED 7 by storing x80 to memory pointed by GPIOC ODR. It again loads R0 with 200 to add to the delay, and now using LSR or logarithmic shift right to shift the number by 1 bit to the right until it reaches 0x00 in hexadecimal. After that, the program will return to the main loop again. The delay subroutine is just 5325 subtracted by 1 for R0 amount of time, and then return back to the loop from before or where the link register pointed to.